to concatenate our string with another string, and we use the greeting variable again. So greeting is just a pointer to slot 2. It does not know what object is in that slot, and it is trusting us to make sure that that object is consistent. So in the absolute worst case, it is possible that memory could have moved around in the heap, and your variable is going to pull an object that is not what it expects. It's going to return wrong data to your users or behave unexpectedly. In a better case, maybe it'll just segfault and crash, and then you'll at least know there's a problem, but it could silently work, but just do the wrong thing for a really long time. So luckily, the Ruby maintainers have thought through this case as well. They changed the behavior of the existing Ruby methods so that the method that marks objects also pins an object in memory. And pinning an object is pretty intuitive. It's like if you literally just stuck a pin into a piece of paper on a board, someone could not go and move that around. So starting in Ruby 2.7, when you mark an object for garbage collection, that object is not going to move during memory compaction. And you can see on this slide, like the idea is that whatever object is in this little yellow slot does not move during memory compaction, even though it would if it wasn't pinned. You can see this in the code, even though the maintainers of Ruby have made this somewhat invisible. So they changed the RBGC mark method such that it pins objects in the heap. If you look at the code itself, you'll see that there's now a method called RBGC mark pin and another one called RBGC mark no pin. And so this one is actually calling RBGC mark pin so that any object that you mark does not move around in the heap during memory compaction and prevent any of this like memory weirdness that a user might experience. So armed with this information, I had everything I needed to sort of deduce the problem that was going on in my gem. So I knew Ruby garbage collection, it pins all marked objects starting in Ruby 2.7. Any object that is pinned will not move in memory. Some object in my gem was moving and causing segfaults. That means that the object must not have been pinned, which means that it was not being marked. And so I had to figure out where we were doing something wrong in marking an object. So as I talked about previously, there are kind of two places where you really have to be careful with marking objects in Ruby C extensions. The first is not marking a long-lived object as a root. And then the second is not properly marking references in a mark callback. So it just so happened that not marking a long-lived object was the problem in our gem. This is code from the bson gem. You'll see that there is a variable called RB registry that's being initialized in the init bson native method. That's the initializer for the bson C extension. This object was being created in the initializer, used throughout the gem, but it was never marked. I believe it never had to be. It was never a problem that it wasn't marked because it was actually a Ruby module, and modules aren't garbage collected. So I think like from a garbage collection standpoint, it actually ended up being fine. But as soon as you introduced compaction, this object was not being pinned in memory and was being moved around and causing all sorts of segfaults if you called GC.compact. So all I had to do was mark that object in the initializer so that it would be pinned in memory, and the segfaults immediately stopped, and I had finally solved this bug. what I've talked about so far is focusing more on how to make an existing C extension compatible with memory compaction, assuming you have had to support Ruby versions older than 2.7 and continue to have to support those Ruby versions. Doing this won't take full advantage of memory compaction because what you're essentially doing is preventing some objects from moving. And so that means that, if we think back to the slide where we had our nice like empty heap pages, that's not going to happen necessarily because you are keeping some objects in place. So if you happen to get the chance to write a new C extension, you can take full advantage of memory compaction without having to pin any objects in memory. You can support them moving around, and this is how. So the first is by using RBGC mark movable in your mark callbacks. So in the previous example, we just used the RBGC mark method. That method, as I said, pins an object in memory, so it will not move around. This method allows an object to move in memory. They will not be pinned. But then you have to account for the fact that they might move around. And so there's a new type of callback introduced in Ruby 2.7. You also have to add a compaction callback. This method always gets called after memory compaction in order to help an object update its references so that it knows where the other objects it references now live in memory. And in this callback, you just have to make sure you call RBGC new location on every reference within your object, and that will update the locations in memory of those objects. So I think there are two main things that I took away from this experience. The first is that understanding like system design, and in this case, like language design, can be just as important as coding. Often, we do our best work when we get to code really fast and we understand, like object-oriented design patterns. But sometimes an understanding of how a language is actually put together can make all the difference in whether or not you're able to solve a hard bug. And so I think that's a skill that like I haven't focused on very much, but will do so in the future because I now understand that it can sometimes be crucial to being a good developer. And then the second thing that I learned is that knowledge sharing is very crucial, especially in an area where there is not a lot of documentation or knowledge to begin with. So I don't know how many of you have spent time researching C extensions, but the API is basically not documented by any official source. And everything that exists about it was created by people who just wanted to create educational content for other people in the Ruby community, and Aaron Patterson, who is implementing most of these new memory compaction features. So those people, took time out of their work and out of their lives to create these resources that ultimately helped me solve this bug. And I would not have been able to do it if they hadn't sat down to do that work. So I think if you have been thinking about writing a blog post or doing a podcast episode about a certain topic and you've stopped yourself and said, oh, I don't know if the world needs to hear this, I would say they do. And the knowledge that you share with your community and with the world may just, get someone through when they have to really solve a hard bug. I referenced some awesome sources in this talk, and I will once again put these slides in the chat so that you could click on these links. I would highly recommend reading these articles and watching these videos. And this is a summary of what I've shared. My last point, nothing is impossible if you believe in yourself and your 1,000 browser tabs. Thank you for coming to listen to this talk, and I'd love to take any questions.
First of all, thank you, Emily. That definitely was fantastic. Yeah, cheers. Yeah, everyone, feel free to ask questions, unmute yourself and ask away, or if you want to, just put something in the chat.
I had a quick one, maybe.
Mhm.
Are you able to unpin something for later garbage collection?
Yes. So essentially how the early implementations of manual garbage collection work is first they run, or manual compaction work, sorry, is first compaction runs a full garbage collection, a full series of garbage collection, like it marks and it sweeps. Then it does the memory compaction, and then it does garbage collection again. This is like a very slow implementation, but it works and is like good for the purposes of an initial initial introduction into the code base. And so how marking actually interacts with pinning is that if you call compaction and you call compaction and that calls garbage collection. Garbage collection will mark and pin an object. And then once that whole compaction cycle has completed, the object will be unmarked and unpinned. So it hypothetically could be moved in the future if something happened that where it wasn't pinned first. But for the purposes of that one cycle of memory compaction, it will be pinned.
I have a question.
Yeah.
So you mentioned that for, in your BSON gem that you added you used the C extension, and you said some reasons that you would use a C extension, like performance, and then you said or other reasons. For the BSON gem specifically, was it performance or was it something else?
So I think the BSON gem essentially just manipulates binary strings, which I think is pretty performant and straightforward to do with C. And by straightforward, I don't mean easy, but I feel like C is built for that sort of low level manipulation, whereas Ruby is not as suited for that sort of task. So I think just based on what this gem has to do, C is a more suitable language.
Totally makes sense.
Yeah. And then all of just the high level kind of API is exposed in Ruby.
Yep, for sure.
Yeah.
Cool. Thanks.
Yeah, thank you.
I have one. Emily, I guess during your process of fixing it or afterwards, have you thought of any testing that could be or should be added to the gem to kind of try to surface these things?
Yes. Actually, this is an idea that my former colleague Oleg contributed, so I just want to give him credit for it, and this is a brilliant idea. So we have a bunch of different test setups, and so we created a new environment where the tests are run, and in that environment we periodically run GC.compact with some random probability. And so if any bug related to memory compaction is introduced in the future, this test environment will catch it. And the way the testing at MongoDB works is all these environments are run when we contribute a pull request. So I thought that was a really good idea, and that's how the tests are currently being run.
Awesome, cool.
Yeah.
Did the person who opened the bug originally actually have a frowny face? That was their contribution? No. Okay.
No. That was just playful, and if that person is here, I'm not trying to spread libel about you. No, they everyone who interacts, and I think everyone in the Ruby community is so sweet, and so many of the contributions and the tickets we would get at MongoDB were also very kind and very supportive. So that was more playful than anything.
Oh, okay. Good to hear the legend lives on.
It's true.
Cool. Any other questions?
You hinted at GC.compact being part of Ruby 3. Does it just become garbage collection at that point?
That's a great question. And I'm not sure. There's going to be a talk at RubyConf about it, which I am really excited about. So I'll let you know. I don't know the answer. Because and to tack onto that, I'm sure there's like some nuances on how long this process takes, because Ruby garbage collection, it doesn't happen in parallel with like running your code. It's stop the world garbage collection. So like your program actually pauses in order for Ruby to garbage collect. And so I think they've definitely improved the performance of memory compaction, but I'm not sure how frequently they would actually want to run it.
It's interesting, actually. I think you might have covered it, but maybe I missed it. But so it sounds like GC.compact is something that one would do in your own program, like at your own time, basically. Like, hey, I feel like right now is a good time for me to clean things up. What's the traditional reason? Like, when would one do this, basically? Like after completing a big operation or something like that?
Yeah, that's a great question. I haven't read any suggestions on that. And I think the person who submitted this ticket, they were just sort of running it like after specific operations. One thing that I do know about GC.compact is that, and this is something Aaron Patterson says, like it's like the bigger your gem, like the more it does, or something like that. I botched that saying, but the more memory your gem allocates, like the more effective memory compaction is, just because like more objects are going to be collected and there's going to be like more to actually compact. So I imagine if you can identify points of like heavy load in your app and identify times when like a lot of those objects from that point are going to go out of scope and are likely going to be garbage collected, then that would be a good time. But I don't think I've read any best practices.
So kind of like a combination of profiling the memory of your own application and then the knowledge of your own application. Then you're like, okay, well, now might be a good time for me to lose some memory.
Yeah, exactly. Yeah, and I imagine you'd also want to do some benchmarking on like, does adding GC.compact into the mix like slow your application down significantly? I'm not sure if it would, but I imagine that's something people would want to keep an eye on.
Yeah. Cool. Okay. Anyone else? Any questions? Comments? Okay. Well, Emily, thank you so much. And you said next week your talk is at RubyConf?
Yep, next Wednesday.
Next Wednesday. Okay. Yeah, if anyone's attending, obviously, please, give Emily your support. Otherwise, that's, yep, I agree on the excellent use of animal GIFs. By the way, yeah, the presentation, I like the draw, obviously, I think worked really well to transition to the fairly heavily technical topic, or very technical, actually. Well, we've had a few job postings, a few job availabilities. If you did not catch them, let me know in chat and we can resurface them. I think the whiteboard might be gone. And then we do have a December talk on Dan Moore, who is, I believe, from the Denver, Colorado NYC meetup. Sorry, NYC meetup, Ruby meetup. Oh my God. He's the co-organizer there. He'll be talking about JWT. And we'll obviously, send that out and schedule on our meetup. Well, thank you so much, Emily, and thank you so much, everybody else, and have a great rest of your evening.
Thank you.
Thank you so much for
Thank-
having me.
Thank you. Thank you.
Thank you, everyone.
Cool. Right. Bye.
Dimitri, if we want to post jobs for future meetups, how do we do that? Because we actually are hiring in our company.
Just you can send us a message through the meetup group. That's one option. Or send it, I'll send you my email. That's another option that might just work better since you and I are talking about it right now.
Okay, yeah, that'd be great.
Yeah, the only thing, cool, I sent it to you.
Dimitri, can you send it to me as well? We are also hiring.
Awesome.
Thanks.
Love to hear that.
Don't steal any great candidates, David.
Why are you working at Contently, Brian? This is a position.
I really like it here.
Ooh.
I didn't hear what he said, but
I mean, I think he was asking, why are you working at Contently trying to hire you? I think that's what was happening there.
oh, I don't know.
You got it.
Contently's awesome. It's a fun team, but we need some. We need like 1 or 2 more people.
Yeah.
Cool. Well, we'll both send an email in. We'll include it in our next newsletter, as well as in the sort of the whiteboard opening to the next meetup. I feel like the newsletter probably has like a wider reach, but both cases are, both places are great.
That's good.
Awesome.
Thank you very much.
Okay.
All right, guys. See you again.
All right. Bye.
Thank you.
Thank you. Have a good night.